Hello viewers, I welcome you to another episode of Mathematics Doddle program on Glorious Vision Television. Today, we are still on algebraic fraction. Algebra. From it, we have algebraic fraction. We want to see how we can be treating algebraic fractions. Addition and subtraction of fractions with monomial denominators. Addition and subtractions of fractions with monomial denominators. At the end of this very lesson, I'm expecting you to be able to add algebraic fractions whose denominators are monomials. That is one. And two, you should be able to subtract algebraic fractions whose denominators are monomials. Get hold of your writing materials and let's go.
Mathematics Doddle.
Yeah, welcome back to the class. Addition and subtractions of fractions with monomial denominators. Addition and subtraction of fractions with monomial denominators. First of all, what is monomials? What is monomials? Monomials, okay, let's start from that so that you will understand what we are about to do. Monomials are algebraic expressions with only single term. Monomials are algebraic expressions with single term. With single terms. Monomial okay, this is an algebraic expression with only one term. Okay, that is that. Example of monomials. Are A, 2B, 5K. Okay. 3PK, and so on and so forth. Okay, just a single term, a single algebraic term. Look at this. 2K plus B. This algebraic expression is not monomial because this is not a single term but two terms. Take note of that. So that is different to that, okay? These are single term. Each of these expressions are singles. That is that. Now, so when we now say, let's now go. We now say we want to deal with monomial denominators, fractions with monomial denominators. Okay, we want to see how we can add and subtract fractions. What fractions? Fractions with monomial denominators. That is, so what are the fractions with monomial denominators? Fractions with monomial denominators are referred to as fractions whose denominators are monomials. Okay? Fractions whose denominators are monomials. Let's write it. Fractions whose denominators are algebraic expression of only one term are referred to as fractions with monomial denominator. Okay, they are referred to as fractions with monomial denominators. Okay, fractions whose denominators are algebraic expressions of only one terms. Okay, only one terms are referred to as fractions with monomial denominators. Okay, example of this. Example would be, we have 3 over a 1 over 3s square. Okay, we have 6 over 5 ABC, and let's say and x over y. This 4 is okay. 3 over a is an algebraic fractions with monomial denominators. This is a fractions. The denominator we have here is an algebraic expressions and also a monomial with a single algebraic term. 1 over 3s square. 3s square firstly is an algebraic expression. The denominator we have here is an algebraic expression as well as a monomial. It is not a binomial. Okay, it's a monomial, that is a denominator with a single term. 6 over 5 ABC, okay, is also a fraction of an with a monomials as the denominators. X over y is also an example of fractions with monomial denominators. Now let's go and see how we can add this type of fractions together. Fractions with monomial denominators. I would like you to note this. Take note that 3 over a plus b (6 over 5 A, B, C minus 1 are not fractions with monomial denominators. Okay, so take note of that. There are difference between this and this. Okay, the denominator we have here are not monomial because we have more than a term at the denominator. Though the denominators are algebras, okay, they are algebraic expressions, but not monomial. They are not single terms. We have two terms here and we have two terms at these denominators. So take note of that. Don't mix them up. All right. Now let's move to how we can add, that is additions of with monomial denominators. Now, example. Example 1. Simplify the following. A 1 over 3a plus 2 over 3a. B C over 4a plus 1 over 4d. C 2 over a plus 3 over b. D b over 3a plus c over 9a. Okay, so this is what we have. A, we have to simplify each of the following. A 1 over 3a plus 2 over 3a. B c over 4a plus 1 over 4d. C 2 over a plus 3 over b. D b over 3a plus c over 9a. Look at these algebraic fractions. You discover that each of the fractions have their denominators to be monomials. Okay, so we are on the right track. Now let's see how we can add the fractions, the given fractions, one after the other. A, we have 1 over 3 a plus 2 over 3 a. Look at these given fractions, algebraic fractions. You discover that they have the same, they have common denominators. Okay, they have the same denominators. So this is an easy, it will be easy for you to add together. Okay, what you just need to do is to write out the common denominators, which is 3a, and add their numerators. That is all. Okay. So 1 plus 2 will give you what? 3. Okay. So we have 3 over 3a. And this, we cancel out this. 3 in 3, that is 1. That 3 in this 3 will give us 1. So we have what? 1 over a. So, which is our final answer. So the addition of 1 over 3a and 2 over 3a, that is the sum of 1 over 3a and 2 over 3a gives 1 over a. That is that. Now let's move to the next one. So whenever you have common denominators, either algebraic or not, okay, either algebraic fraction or not, when you are adding any fractions together, but they have common denominators, what you just need to do is write out their common denominators and add their numerators, even if the fractions you are adding are more than 3, even 3, 4, 5, even you are adding 10 fractions together, if they have common denominators, if their denominators are the same, just write out the denominators and add their numerators. That is it. Now B, what we have here is C over 4a, okay, plus 1 over 4d. Now, looking at these fractions, we discover that they don't have a common denominators. The denominators are not the same. This denominator here is 4a, the denominator here is 4d. What are you going to do? Now, I will do this in 2 ways. Okay. First, we will find the LCM. I've taught you how to find the LCM of algebraic expressions. Okay. We have 4a is an algebraic expression. 4d is also algebraic expression. So let's look for the LCM. To look for it, what is the LCM of 4a and 4d? The LCM of 4a and 4d is 4ad. I've taught you how to do that. Okay. Now you now say 4a in 4ad. This first denominator we have here, okay, you divide the LCM by the first denominator. 4ad divided by 4a, what will it give us? Let's do it here. 4ad over 4a. Okay, so 4 we cancel this 4, a we cancel this a, we have d. So 4ad divided by 4a will give us d. D multiplied by this numerator you are using on this fraction will give us cd. cd. Now this arithmetic operation plus, you write it there. Then 4ad, the LCM, divided by 4d, the second denominators, what will it give you? It will give you a. That is 4ad over 4d. D we cancel this d, 4 we cancel this 4, we have a. Alright, so a multiplied by this one will give you a. Okay, so can we add? We cannot find the sum of cd plus a. cd plus a is still the same cd plus a. Okay, so our answer is finally cd plus a over 4ad. Don't say that you want to cancel out that a into a. No, you can't do that. Okay, and if you like, you can rearrange it as a plus cd over 4ad. I'm not saying that this answer is not correct. It's correct If you only like, you can rewrite the numerator as this, that is all. But it's still the same thing, no difference. You have not changed anything. Okay, that is that. Now that is one method. Or C over 4a plus 1 over 4d. Okay, since they are not of the same denominator, they are not common denominators, what we can do is we can express each of these fractions to be of common denominators. How do we do that? The denominator we have here is 4a. So C, this will give us C over 4a multiplied by d over d. Okay, plus 1 over 4d multiplied by a over a. Now, why I multiply c over 4a by d over d is that d over d gives us 1. D over d is 1. So all this fraction, d over d is 1. 1 multiplied by this will still give us this same value, this same fraction. Okay? So likewise, a over a is 1. 1 multiplied by this will still give us 1 over 4d. We still this. So the whole of this expression is the same with this given fractions. This is given expression. Okay? So we have not changed anything. Now, this will now give us CD over 4AD. C multiplied by D, CD. 4A multiplied by D will give us 4AD. Okay? Plus 1 multiplied by A will give us A over 4D multiplied by A will give us 4AD. Okay, the essence of doing like this is what we call equivalent fraction. Okay, so I found the equivalent of this fraction. CD over 4AD is an equivalent fraction of C over 4A. Likewise, A over 4AD is also an equivalent fraction of 1 over 4D. Why did I say they are equivalent? If I make this division, D will cancel this D. I still have back my C over 4A, which is this. A will cancel this A. I will have back my 1 over 4D. Okay? Now, the essence of using this method is that I want to have common denominators so that it will be easy for me to add the two fractions together. And this will give us, because we have common denominators now, I'll just write out the common denominators, which is 4AD. Okay, and add the denominators CD plus A. Okay, I've told you that if you want to add fractions with common denominators, you just find the sum of their numerators and express it as the denominator of the common denominators. That is that. So can you see that we have our same answer here? So this is our answer. Don't forget that I've said you can leave it like this or re-express it as this. That is that. So now let's move to the second, to the third question, which is question letter C. We have 2A, 2 over A plus 3 over B. Question C. 2 over A plus 3 over B. Okay, now the denominators are not common. They are not the same. Okay, these are not like denominators. So what do? Let's use the second. Okay, we can use anything. So can use any of the methods I've used to find the sum of the fractions we have on question letter B. Okay, so this one will just find the LCM of AB. The LCM of AB is AB. The LCM of A and B, not the LCM of AB. Okay, the LCM of A and B is AB. Now it is the product of A and B. Now A in AB will give us B. B multiplied by 2 will give us 2B. And I write the plus sign here out. B in AB will give us A. A multiplied by 3 will give us 3A. Alright, so what do? We have 2A plus 3A cannot be added together. Why? It's just like this. 3D plus and A cannot be added together. Okay, so this is B. The letter we have there is B. The letter we have there is A. If it were to be 2A plus 3B, the sum of this can be found. It will give us 5B. Okay, and if it were to be 2A plus 3A, the sum will give us 5A. But because they have different variables, different letters, the sum cannot be found. We leave it like that as 2B plus 3A over AB, and this will be our answer for that. Okay, now let's move to the next question, which is question letter D. Question letter D. B over 3A plus C over 9A. Okay. Finding the LCM of this will give us 9A. How did I get that? Okay. So we now write it out, 9A. Okay. So now say 3A in 9A, that is 9A divided by 3A. That will give us what? That will give us 3. 9A over 3A. A, you can see A, 3A1, 3A9 will give us 3. So we have 3. 3 multiplied by B will give us 3B. Okay. We have our plus sign operation. 9A in 9A, that is 1. 1 multiplied by C will give us C. So our answer is what? 3B plus C over 9A. All right? Or you say B over 3A plus C over 9A. Okay? You can say this give us B over 3A multiplied by 3 over 3. Okay, these are equivalent fraction of this. Okay, plus C over 9A. All right, so which will give us B times 3 will give us 3B over 3A multiplied by 3 will give us 9A. We have plus C over 9A. Okay, I use the second method. What I use here to understand. That's what I use there. Okay, so That is that. Now, so this now give us common denominators. So to give us what? You write out the common denominators, which is 9a. 9a in 9a, that is 1. 1 multiplied by 3b will give us 3b. Plus sign operations. 9a in 9a, 1. 1 multiplied by c will give us c. And this will be our answer, okay? Which is the same as this. I hope you understand all what you have done so far to this length. The next example says, we are asked to simplify each of the following. Okay, following. A, we have 1 over x plus 2 over x. B, 1 over x plus 1 over y. C, 2 a over 3xy plus 5 over xy. Okay, now I will have to treat this with less much explanation. Okay, now solution. Since I've explained in details the previous examples, you understand the previous examples, you need to go along with me. Now let's start proper. A, we have 1 over x plus 2 over x. Notice that we have common denominators here, which means that the denominator the next denominator we are going to have is what? Is x. Okay, and this will give us 1 plus 2. Okay, just sum up the numerators to give you 3 over x, and this will be the final answer to be given as an algebraic fraction. Now B, we have 1 over x plus 1 over y. Okay, the denominators are not common, are not alike. Okay, they are not the same. So you find the LCM of x and y. Finding the LCM of x and y will give you xy. So we are going to write that xy as your new denominator. All right, so which is this? Now x in xy, that is xy divided by x, that will give you y. Y multiplied by 1 will give you y, and you have your plus sign operation as this. Y in xy will give you x. X multiplied by 1 here will give you x. Okay, and you have your final answer as y plus x over xy. If you like, you can write it as x plus y over xy. It's still the same. Okay, if you don't want to write y first. All right, and these two letters cannot be sum up to give you another thing to write. So y plus x is the same thing as y plus x. That is that. So that's why we leave it as that. C, we have 2a over 3xy plus 5 over xy. Okay, this will give us what? To find the LCM of 3xy and xy. The LCM will give us 3xy. Okay, the LCM of these two denominators, okay, that is lowest common multiple of these two denominators is 3xy. So we have 3xy as your new denominators. Please ensure to go back to the last episode of this program and check how to find lowest common multiple of a set of given set of algebraic expressions. I've explained there how we can be finding the lowest common multiple, LCM, least common multiple of any set of algebraic expressions. Okay, now so 3xy in 3xy is 1. 1 multiplied by 2a will give us 2a. Okay, and we have plus sign here, operation in between of these two given set of fraction, algebraic fraction, which is this. Xy in 3xy will give us 3. 3 multiplied by 5, we have 15. That is that. So 2a plus 15. To add these two together will still give us that same. Okay, will give us same. So there's nothing we can do about it. Okay, and 2a plus, so we eventually have 2a plus 15 all over 3xy. That is that. I hope you understand to that level. So that is that. Now let's move a bit forward to find how we can subtract fractions with monomial denominators. I want to see how to subtract fractions, how to subtract one fraction from the other. Those fractions that have monomials as their denominators. Stay tuned.
Mathematics Doddle.
Now, subtractions of fractions with monomials denominators. Example what now? On example 3. Simplify a 5 over 3b minus 2 over c. 1 over 3c minus 2a over 4d. C, sorry. We have x over 15 minus 2x over 25. Solution. A, 5 over 3b minus 2 over c. We find the LCM to give us, and that LCM, we find the LCM of the denominators. We have 3b to be the denominator here, and we have c to be the denominator of this fraction. Okay, so the LCM of 3b and c is 3bc, and that will be the new denominator, 3bc. All right, so now I say 3bc divided by 3b, that will give us c. C multiplied by 5 will give us 5c, and we have minus sign. That is that. C in 3bc, that is 3bc divided by c, okay, will give us 3b, and 3b multiplied by 2 will give us 6b, okay, will give us 6b, and that is our answer. There's no how to add this denominator, and this numerator, sorry, there's no how to add this numerator, not denominator, numerator, okay, that is 1. And 2, we cannot even factorize. We would have thought of factorizing the numerator. We don't have any common values here or common variables. We have decided to factorize it, okay, that is that. So the subtracting 2 over 3, this fraction, from 5 over 3b gives us 5c minus 6b over 3bc. That is the meaning. All right. B, we have 1 over 3c minus 2a over 4d. Okay. What do we have? LCM. The LCM is what? 12CD, and the LCM divided by the first denominator will give us 4D. 4D multiplied by 1 will give us 4D. Okay, for this LCM again divided by the second denominator, that is 12CD divided by 4D, will give us 3C. All right, will give us 3C, and 3C multiplied by 2A, this is minus sign operation, we're writing it out. So 3C multiplied by 2A will give us what? 6AC. All right, so that is that. Now to subtract 3AC from 4D, we cannot subtract 6AD. Don't come and say 4 minus 6 will give us 2. No, don't do that. Okay, before you can make that simple subtraction, okay, these variables we have here, these letters must be the same. It's either you have 4AC here, as you have add 6AC here. So if you have 4AC, you can subtract, you can now deduct 6AC from 4AC. Or as you have 4D here, what you're having here is 6D. So you can subtract 6D from 4D. Okay. Now, but the way they are now, or the way this denominator is, you can't do the subtraction, but you can factorize the numerator. You can factorize the numerator. How do you factorize the numerator? Looking at it, we have two terms here. This is one term, this and that term. So we have common factors. What is the common factors? The common factor is 2. 2 is common in this first and second. We can remove 2 from it. Okay, so this will give us, bringing out 2, open bracket, you bring out 2 here, that is divide 4d by 2. We are going to have 2d. Okay, this is your minus sign operation, which is this. So that 2 you have, the common factors you have taken out. Taking out this 6 will enable this 6ac to be 3ac, and you have division line over 12cd. Okay, so we have 2 open bracket 2d minus 3ac. This is ac. Okay, this is ac, or everything over 12cd. 2 here 1, 2 in 12 will give us 6. So we have 2a minus 3ac over 6cd. Question C, we have x over 15 minus 2x over 25. This will give us, we don't have a common denominators. Now I can re-express this as x to find the equivalent fraction of this fraction and this fraction, so that in such a way that they are going to have common denominators. So over 15 multiplied by 5 over 5 minus 2x over 25 multiplied by 3 over 3. Okay, and this will give us x multiplied by 5 gives us 5x over 75 minus 2x multiplied by 3 give us 6x over 25 multiplied by 3 will give us 75. So we have common denominators. Okay, that is the source of finding the equivalent fractions, such a way that they are going to have common denominators. So which will enable us to have a new denominators, which is 75. We have denominator common, this is it, LCM. So 75 is 75, 1 multiplied by 5x will give us 5x. Minus sign, 75 is 75, 1 multiplied by 6x will give us 6x. Okay, this 6x. And this will give us what? Now look at what I've been talking about since that. Now we want to subtract 5x minus 6x can be found. Okay, subtracting 6x from 5x will give you minus 1x. Okay, over 75, and that 1x is the same thing as x. Okay, so which is minus x over 75. That is that. I hope you understand to this length. This is your TACN, your assignment. TACN. Simplify the following. A, we have 2x over 3 plus 3y over 4. B, 1 over 4m plus 3 over 2n. C, we have 5mn over 6 plus mn over 9. D, we have 2 over x minus 3 over 2a. E, we have 15 over 2, 15a, okay, over 2 minus 5a over 2. The last but not the least, which is question letter F, is 18p over 10, all right, minus 9p over 4. That is that. Now, your takeaway is this. The question asks you to simplify each of the following. Question letter A, 2x over 3 plus 3y over 4. Question letter B, 1 over 4m plus 3 over 2n. Question letter C, 5mn over 6 plus mn over 9. You are asked to find the sum. Question letter D, 2 over x minus 3 over 2a. Find the subtraction. E, 15a over 2 minus 5a over 2. Subtract. F, 18p over 10. This is 10, okay? This is 10. Minus 9p over 4. That is that. So, till we meet again, same time, same day, next week, I remain Ayobami Ojo. Till we meet again, bye and bye.